Hello again, welcome to geology. So in that previous video I kind of showed the rocks, but I didn't go into more detail. So rocks, you can pick them up, you can feel their texture. This one feels rough. I can see the color as being black and white. Here's another rock. It's different. The texture is a little more kind of sandy feeling. You can see that the color, the other one was, I said, was more black and white. This is more kind of green and white. It's made differently. Here's another rock that's black, and you probably recognize this one. This one is called obsidian. Very different in feel. It's very glassy. Some places feel more, it's smooth, but it feels different. It's places where it hasn't been broken, it's been weathered. Here's a rock that's very common to this area. It's basalt. When you go down the Columbia Gorge towards Portland, this whole area is called the Columbia Basin Plateau. We're part of a giant basalt flow. And so this is very similar to, it was once magma deep underground. When it comes above ground, we call it lava. So it came up deep underground, and it's a type of magma we call basaltic magma, and it forms basalt rocks. And it flows similar to water, and so it's able to cover a large area. So the Hawaiian Islands happen to be made from basaltic magma, and gives them the characteristic what we call the shield volcano. Mount Hood, for example, would be classified as a composite volcano, where it has layers of ash and layers of magma, which is now lava, then hardened into a rock. And then some rocks, you can see this one has some looks like holes, and again, it's going to be a lighter feeling rock. It doesn't feel very heavy. It's because the air pockets are going to give it a low density. Another example of a rock, would call this a metamorphic rock. It was once an igneous rock, and then it cooled and hardened into a rock, and then it might have been exposed to more pressure and heat, and that caused the crystals to form. So it's got little lines in it, and those are actual crystals. And again, it's a process of how it's formed. So chemically speaking, if I were to look at the atoms of this and the molecules that make up this, that it has a certain structure, we would find that the obsidian, if we looked at it chemically, would probably be very much the same chemicals. It's just a matter of how fast they cooled. This would have cooled deep underground and cooled slowly, allowing the crystals to form. This would have been formed at the surface of the earth and cooled very quickly, and not given the crystals a chance to form. It's almost like one giant crystal. But again, it's considered like a glass, not really a crystal structure. Now this rock looks like a sedimentary rock. It kind of looks like it's been glued together like cement. If any of you have ever worked on making a sidewalk or foundations, we use cement to build things, and nature does the same thing. You have chunks of rock. They look very similar to this basalt rock over here, and so sand and other materials get in between those rocks, and they will get heat and pressure. Maybe not necessarily heat, but pressure. Those crystals will grow together, just like we do cement, but it's nature cement, and it'll form a sedimentary rock. So that's just, again, another way of thinking about what's in geology, and I hope you have a good year.